Time doesn't pass at the same speed everywhere in the universe. It stretches, it bends. And near powerful objects like stars and black holes, time actually slows down. This isn't science fiction. It's Einstein's theory of relativity. And today, we're going to make it finally make sense. Time feels constant. 1 second is 1 second. A minute is a minute. But physics says time is not fixed. It's a dimension, like length or width, and it can stretch or compress depending on where you are and how fast you're moving. This idea shocked scientists when Einstein first proposed it, but today, we measure it every single day. In fact, the GPS satellites that help you navigate only work because their clocks tick slightly faster than clocks on Earth, and we must correct for that difference. Time dilation is real. Einstein discovered that gravity isn't a force pushing down. It's the curvature of space-time caused by mass. The stronger the gravity around you, the slower time moves for you. This means clocks tick slower near the surface of Earth, faster on mountains, even faster in orbit. If you live on the ground floor of a tall building, you actually age slightly slower than someone on the top floor. The difference is tiny, fractions of a second across your lifetime. But near extreme gravity, like a black hole, the effect becomes dramatic. Close to a black hole, time slows down so much that it almost stops. Imagine hovering near a black hole for 1 hour. When you return, hundreds, maybe thousands of years may have passed in the outside universe. This is called gravitational time dilation. Your experience, 1 hour. Everyone else's experience, centuries. This is one of the strangest consequences of relativity, and one of the most powerful. Gravity isn't the only thing that affects time. Speed does too, the faster you move. To really see this effect, physicists created the twins paradox. Twin A stays on Earth, Twin B travels into space at near-light speed, then returns. Twin B comes back younger, not metaphorically, literally younger. This is not a trick. It's not theoretical. It's been tested with atomic clocks. Time dilation affects the flow of reality itself. The slower time passes for you. Astronauts aboard the International Space Station move at 27,000 kilometers per hour. And because of this, they age a tiny bit slower than people on Earth. In fact, the fastest humans ever have experienced milliseconds of time dilation. If you could travel close to the speed of light, you could return after 1 year, while hundreds of years passed on Earth. Your future could be someone else's distant past. Here's the mind-blowing part. Time dilation is a kind of one-way time travel into the future. Travel fast enough, or near enough to extreme gravity, and you can skip ahead in time. Not backwards. Physics doesn't allow that. But forward? Absolutely. If humans ever build near-light speed spacecraft, future astronauts could leave Earth and return to a world transformed. They wouldn't just explore space, they would explore time. Time isn't fixed. It bends, stretches, and warps depending on gravity and speed. Understanding time dilation brings us one step closer to understanding the universe itself. If you want more mind-bending science explained simply, subscribe and join us for the next journey.